Hello students, welcome to Engineers Academy. Now we are going to solve this problem which is related to fundamentals of physics, and the problem says that the position of a particle moving along an x-axis is given by x equals to 12t square minus 2t cube, where x is in meters and t is in seconds. Determine the position, velocity and acceleration at t equals to 3 seconds. So we are given that x is the position of a particle is given as a function of time, which is equal to 12t square minus 2t cube. So we are asked to find the position, velocity and acceleration at t equals to 3 seconds, right? So we can say that x at 3 seconds, if I put t equals to 3, then we will get the position at x equals to 3 seconds. So we will have 12 into 3, which is t square. So 12 into 3 square minus 2 into 3 to the power 3. This gives us x equals to 54 meters. And to find the velocity, we have to, since we know that velocity as a function of time will be equal to the derivative of fx x of t function. So we can say dx of t divided by dt. So if we take the derivative of this function, we will get the velocity equation, or we can say we will get the velocity as a function of time. So this will be 2 times 12, so that will be 24t minus 2 into 3 is 6t square. And to find the velocity at 3 seconds, we have to put t equals to 3 in this equation, so which will be 24 into 3 minus 6 into 3 square. This is equal to 18. So this is equal to 18 meter per second. So the velocity at t equals to 3 second is 18 meter per second. And now the acceleration as a function of time will be equal to the double derivative of x of t function, or we can say dv by dt. So we can say that dv of t divided by dt, or we can say dx square t divided by dt square. So we can say that if we take double derivative, this will be d square x of t. So if I take the derivative of this, or if I take double derivative of this equation, we will get the acceleration. So if I take the derivative of this, that will be d square x of t divided by dt square, or this. So we can say this will be 24 minus 6 into 2, 12t. So now putting t equals to 3 seconds in this equation, we will get the acceleration. So 24 minus 12 into 3, this gives us acceleration at 3 seconds is equal to minus 12 meter per second square. So this means that at t equals to 3 seconds, the particle is deaccelerating. So this is the solution for A, B and C. And now the part D says that what is the maximum positive coordinate reached by the particle. So since it is said that the particle is moving along the x-axis direction, along the x-axis, so we have to find the maximum positive coordinate. So the maximum positive coordinate will be the point where the velocity will become zero, or where the particle will stop momentarily. So we can say that to find the solution for point D, the maximum x coordinate will occur when velocity is equal to 0. So we have the velocity equation, which is 24t minus 6t square. This is equal to 0. And from this we can say that minus 6t square is equal to minus 24t. Minus will cancel out. 1t will cancel out. And we can say that t is equal to 24 divided by 6, or t is equal to 4 seconds. So at t equals to 4 seconds, the particle position will be at maximum x coordinate. So we can say that at t is equal to 4 seconds, the velocity will become 0 and the x coordinate will become maximum. So if we put t equals to 4 seconds in this x of t equation, we will find that maximum positive coordinate. So we can say that x of t at 4 seconds, which will be the maximum positive coordinate, and that will be equal to 12 t square, so 4 square minus 2, 4 to the power 3. So this is, we can say, 12 into 4 square minus 2 into 4 to the power 3. This gives me 64 meters. So x 64 meters. So this is the maximum positive coordinate. And similarly, this is the solution for part D. And for part E, it says that at what time is it reached. So this is the solution. This is the answer for part E. So at t equals to 4 seconds, the particle will reach at the maximum coordinates of 64 meter. Now part F says that what is the maximum positive velocity reached by the particle. So now as we know that the maximum, when the velocity is maximum, the slope of the velocity graph will become 0. And the slope of the velocity graph is the acceleration, or we can say that dv divided by dt is the slope of v of t function. So for part F, which says that find v equals to v max. So for v max, the dv by dt graph, the slope of the velocity graph must be equals to 0, and the slope of the velocity graph is the acceleration as a function of time. So we can say that dv by dt, which is equal to acceleration as a function of time, this must be equals to 0. If the slope is equals to 0, then the velocity will be maximum. So we can say that if we equate this acceleration function equals to 0, we will get the time. So 24 minus 12t, this is equal to 0, and from this we can say that minus 12t is equal to minus 24, and from this we can say that t is equal to 2 seconds. So at t equals to 2 seconds, the velocity will be maximum. So now if you want to find the maximum velocity, we have to put t equals to 2 seconds in this equation, v of t. So we can say that velocity, or we can say that v max will be equal to velocity at 2 seconds, and velocity equation is 24 into t. So now t is 2 seconds minus 6 into 2 square. So this will give us 24 into 2 minus 6 into 2 square. This is equal to 24. So v max is equal to 24 meter per second. So this is the answer for part F of this question. Now part G says that at what time is it reached the maximum velocity. So the time is t equals to 2 seconds. So this is for the solution for G. And now part H says that what is the acceleration of the particle at the instant the particle is not moving, so other than t equals to 0. So as we have determined that at t equals to 4 seconds, the velocity is equal to 0. So if the velocity is equal to 0 at that particular point, part H says that we have to find the acceleration. So we can say that for part H, the acceleration at t equals to 4 seconds, when the velocity is equal to 0. So when the velocity is equal to 0, we have to find the acceleration. Now the acceleration, since we know that at t equals to 4 seconds, velocity is equal to 0. So we must find the acceleration at t equals to 4 seconds. And the acceleration equation is 24 minus 12t. So 24 minus 12 into 4. So we can say that 24 minus 12 into 4, this gives us minus 24. So this is equal to minus 24 meter per second square. And similarly, the last part says that determine the average velocity of the particle between t equals to 0 and t equals to 3 seconds. So part I is we have to find the average velocity for t equals to 0 until t equals to 3 seconds. So we know that the average velocity will be equal to the velocity at 3 seconds minus the velocity at 0 seconds divided by 3 seconds, or we can this is 3 minus 0. So the velocity at 3 seconds is, we know that the velocity at 3 seconds is 18 meter per second. So here this will be 18 minus the velocity at t equals to 0. So if we put t equals to 0 in this equation, 24 into 0 is 0 minus 0. So velocity at t equals to 0 is 0. So we can say that 18 minus 0 divided by 3 minus 0, and this will be equal to 18 divided by 3, which is equal to 6 meter per second. So the average velocity is 6 meter per second. Now for the reference, I have drawn these three graphs, and this red one is showing x of t graph. So we can say that this is the red one is x of t, and the blue one is velocity as a function of time, and the green one is the acceleration. Or we can say that this one, the straight line, is the acceleration. Let me extend this. This is the acceleration as a function of time. Now, as you guys can see that the maximum x coordinate is 64 meters. This is 60. So somewhere here is 64. So we can say that the maximum x coordinate is plus 64 meters, and the velocity is maximum at t equals to 2 seconds. Here you guys can see the velocity is maximum at t equals to 2 seconds. Now this is the velocity graph. So at t equals to 2 seconds, the acceleration is 0. The slope of the velocity graph is 0. So this is the slope of the velocity graph, which is equal to 0 at t equals to 2 seconds. And at that particular point at t equals to 2 seconds, the maximum velocity is 24 meter per second. So from here we can say that the velocity is 24 meter per second. So somewhere here is 20, this is 24. And at t equals to 2 seconds, the acceleration is equals to 0, which is the slope of the velocity as a function of time graph. And similarly at part H, we are asked to find the acceleration when the velocity is equal to 0. So the velocity at t equals to 4 seconds, this is the velocity. So the velocity at t equals to 4 seconds is 0, and at that particular point the acceleration is somewhere here, which is minus 24 meter per second square. So at t equals to 0, the velocity graph is touching the x-axis and the velocity is equal to 0. And similarly, the average velocity can be found directly by joining the straight line at t equals to 3 seconds. This is at t equals to 3 seconds. Velocity at t equals to 3 seconds, and this is the velocity at t equals to 0 second. If we join both of these points, and finding the slope of this line will give us the average velocity. So if we find the slope of this particular line, which joins the velocity at, this is the point v at 3 seconds, and this is the velocity at t equals to 0 seconds. So if we join these 2 points directly by a secant line, and if you find the slope of this line, that will give us the average velocity. So the slope of this particular line will be this v3, velocity at 3 seconds, minus the velocity at 0 seconds, divided by t equals to 3 seconds minus t equals to 0 seconds. So this is equal to the average velocity, which is 6 meter per second. So this is the solution of this particular problem. I hope this will help you in your learning. Let me know in the comments if this helps. Do subscribe Engineers Academy for the solution of such more problems from Fundamentals of Physics by Resnick Halliday.